I'm gonna solve 21 Java exercises and one big final project at the end. I will cover DB operations with JDBC, multithreading, networking, memory leak, reflection, and generic topics. And I will apply all the learnings in the final mini job server project. If you have any other topic you want me to cover, please comment below. If you are beginner, you may want to check my previous Java beginner exercises video. I will leave the link in the video descriptions below. Before starting, here are my suggestions for you to get most out of this course. Code along actively. Don't just watch. Open your IDE and try to solve problems yourself first. Pause and experiment. Try variations of the examples shown. Keep a learning journal. Note ideas for your own projects as you watch. Okay, let's start with creating an empty project in IntelliJ IDEA. Right-click to the project, mark directory as source root. I have created directories for each exercise to make it simpler. Let's start with Hello JDBC exercise. We need to load PostgreSQL JDBC driver and connect to a PostgreDB successfully for this exercise. Search for the JDBC driver and download. Let's create Hello JDBC exercise class. We can load JDBC drivers by using this class for name method. As we haven't attached downloaded JDBC jar driver into this project, we are getting error. Let's create a new package for third-party jars and put our JDBC driver jar in it. Right-click, open module settings and select our JDBC jar as library. We need to see it in dependencies tab like this. Rerun the application and yes, we don't get error anymore. To connect to a PostgreDB, obviously we need to start up an instance of it, so I will use Docker Compose method to start a Postgre instance. You can check details of how to start PostgreDB via Docker Compose in one of my previous videos. I will leave a link in description. After making YAML file ready, let's start it with Docker Compose app command. Yes, I can see Postgre container is running. Let's connect it via DBeaver. Okay, we can see there is no table yet. Let's put our connection URL and user password details in our exercise and use dbManager getConnection method to get the connection object instance. Yes, we can see connection is successful. Let's move to table creation, insert and query exercise. We need to create a statement from connection instance. Next, prepare the create table SQL. And call executeUpdate method of statement by passing SQL. Let's check from DB. Yes, we can see the students table is here. Now we need to insert one record into students table and then we need to query it. Let's change our create table SQL into insert SQL. Let's print the rows value returned from executeUpdate method. By this way, we can see how many rows are affected. Yes, we can see one row is inserted. Now let's query the students table and print the all items. Now we need to switch from statement execute update to execute query method because we are not updating anything. This execute query is returning a result set and we need to iterate over result set to get each item. Let's run it. Yes, we can see the item in command line. In the next exercise, we will practice update and delete operations and we will use prepared statement to avoid SQL injection. Prepare update SQL statement. Call statement execute update method and print the output. Yes, we can see name is updated. Now practice delete operation. Similarly, prepare the delete SQL statement. And let's run it. Yes, we can see item is deleted. Now we need to insert a student using prepare statement. Let's write the SQL statement first. We need to use question marks to parameterize the statement. Create a new prepared statement instance using connection.preparedStatement method and set values for parameters starting from 1. And finally, call the executeUpdate method of preparedStatement instance. Yes, we can see it is successful. In the next exercise, we will practice calling a stored procedure from Java and a batch insert. First, let's create a function in Postgre. This function is returning student count. Now we need to initialize a callable statement from connection. Then we need to register out parameter as integer and then execute it. We will retrieve the result using this getInteger method. Yes, it looks working now. Now we will practice addBatch and executeBatch methods. First, let's prepare insert into SQL statement. Initialize prepared statement instance and set the values. Call addBatch method and continue to add multiple items. When we call the executeBatch method, those two items will be inserted with only one SQL execution. Yes, it looks fine. In the next exercise, we will observe the difference between batch insertion and one-by-one insertion by inserting 50,000 items. First, let's create the products table. Now initialize the exercise class. In this insert native method, we will insert one by one. Write insert into SQL suitable for prepared statement. Iterate 50,000 times and create product items in DB one by one. We will use prepared statement as we saw in previous exercises. Create product items with random prices. Now let's implement batch version of these insertion. Instead of executing on each iteration, we will use addBatch method and we will execute batch after we reach the batch size we define. Call connection commit to immediately apply the change to DB. Now let's implement helper methods to calculate times. To collect better statistics, we will delete all items between executions, so we are developing this truncate table helper method. Now let's implement main method by calling insert native and insert batch methods. Okay, let's run and observe what's happening. It looks like one by one insertion took 18 seconds, but batch insert is less than 1 second. It is 300 milliseconds. Can you believe how fast this batch insertion is comparing to one by one insertion? Next exercise is pagination. Read product items ordered by ID ascending 100 items per page. Check this pagination formula. You will use it on your jobs a lot, I think. From the UI perspective, if we say page number starts with 1, offset equals page number minus 1 times page size, and limit is page size. Here how we can get first and second pages. Now let's implement this formula in exercise code. Define page size as 100. Implement product record for data transferring. Let's reuse this connection initialization code. Now let's implement our prepare statement. We will read items from DB and put it in this array list. Populate prepared statement parameters according to our formula. As you remember, execute query is returning result set and we need to iterate on result sets. Extract values from result set, initialize a product instance and insert it into items array. At the end, print out the items into console. Okay, looks fine. Let's run it. Yes, we can see the items in console output. Let's break the loop after page 3 to better understand what is happening. Yes, each page has 100 items. Alright, let's move to multi-threading exercises. First, hello from 2 threads. Start 2 threads that print 100 hello messages each. Observe output that messages are interleaved. We use runnable interface to define our workload. So we are passing runnable instances to threads to execute them. In this runnable instance, we are printing current thread name and the index of the loop. Let's initialize two threads and start them. Okay, when we run it, we can see the logs are randomly distributed. Sometimes Virtual 1 says hi, sometimes Virtual 2. In the next exercise, we want to observe the states of a thread. Let's initialize a thread. Give a simple runnable implementation that calls sleep method. Okay, let's start printing the state of thread and moving thread to next states. Print before start, after start, during sleep, and after thread is finished. Yeah, we can observe new, runnable, timed waiting, and terminated states. Next exercise is for thread safety, race condition versus synchronized. Increment a shared integer counter with and without synchronization. Observe lost updates. Let's implement counter class. Here are unsafe increment method. We just add 1 to value. In the safe method, we are using synchronized keyword. In the test code, we call both safe and unsafe ones. In the test code, we will call increment method 1 million times based on the preference, safe or unsafe, and we will observe the results. To simulate race condition, we are running two threads to update same counter instance. Let's print the output. We need this get method. Now let's execute test with first unsafe mode and after that let's run it with safe mode. You see in unsafe results we see wrong value, but safe result is correct. Another safe method is using atomic integer class. That is thread safe by itself and it will not be a problem when we use it in unsafe method. Yep, there is no data loss in atomic integer. Here are possible methods in atomic integer class. Next exercise is about thread pools. Execute many tasks. Use ExecutorService with 3 threads to run 10 tasks. Shut down properly. You can initialize your thread pool using static methods in this executors class. Initialize it with size of 3 as per the exercise. Iterate over loop 10 times and submit work to the pool. At the end, we are calling shutdown method to close it properly. Yeah, we are missing some import here. And we need to handle this exception. Yes, we can see tasks and thread that execute them. Next exercise is about semaphore usage. Playground swings example. There are 3 swings at the playground, but 10 kids want to play. A kid must wait for a free swing for a short time, then free the swing for others. Create a semaphore with fixed number of permits. Represent a kid with a thread that wants to swing a little bit. Use acquire and release methods for swing seeds usages. Define swing seeds constant. We will use this value as permits. And number of kids will determine the number of threads in our exercise. Let's implement the kid class. We will pass ID and semaphore as constructor parameters. As kids arrives random times, let's select random values. Let's put some error messages just in case. Implement this help log method to print out any action. After arriving to playground, kids should wait until a swing is free. That means semaphore allows to acquire it. After acquiring, log that action as well. Simulate swinging with a random sleep. And in the final block, we need to release semaphore. That means kid stops swinging. Now in main method, let's initialize the semaphore. Pass true flag for a fair semaphore. That means first come, first served. Initialize 10 threads representing the kids. For each thread, pass a kid instance and let thread to execute it. Call join method for each thread to wait all threads are done. Okay, let's run and observe the outputs. Each kit arrives and try to get a swing, but if that is not available, it just waits. After some kits released the swing, other ones picked them. Until then, the other kits were not able to get the swing. If you find this video helpful, please like and subscribe so you don't miss the next upcoming videos. Alright, next exercise is about ForkJoinPool parallel computing example. Turn a plain for loop into fork join computation and compare sequential versus parallel timings. Let's simulate hard computation with this heavy math method. Let's define some helpful methods to calculate timings. Define max, exclusive and threshold values. First, let's try with sequential calculation and calculate timings. For each step, call heavy math method and put the result into a map. Secondly, let's implement ForkJoinPool. We need a compute task class that extends recursive action that actually calculates only a small part of the loop. We will split workload according to threshold value. Calculate length value, and if length is greater than the threshold, split the workload as calculated. Splitting means create compute tasks for left hand side and right hand side of the workload and submitting them to ForkJoinPool again for execution. If workload is small enough, that means length is less than the threshold, we are calculating the values in this. And initially submit the compute task starting from 0 to max value and let the ForkJoinPool to split it itself. Let's calculate speedup and we use ForkJoinPool comparing to sequential calculation. Alright, let's run and see the results. Yes, as you can see, fork join time is more than 3 times faster than sequential calculation. Let's run again with printing the splits. Yeah, we can see the start with and end values of each split. When we increase the threshold, we will have less split. Okay, let's move to networking exercises. In this one, we will build a simple chat system where the client sends a message to the server and the server echoes it back. Create a TCP server that listens on port 12345. When a client connects, read the incoming message and send it back. Initialize ServerSocket instance with the required port number. Use accept method to get client connected. Use buffet reader to read values client sends. Use print writer to send some response. Check if message is exit. If then, break the loop. If not, directly respond with the echo. After everything is done, close the sockets. Now implement the client side. As we will run the servers in same machine, we will use localhost to connect. Use system-in to get some input from the user from command line. Again, initialize print writer to send some value to server and buffet reader to read response. In an infinite while loop, read input from user and send it to server until user enters exit. Okay, first run the server and then run the client and let's test it. Write some stuff. Yeah, we got the echo response from the server. Next exercise is guess the number game on UDP protocol. Create a small game over UDP. The server picks a random number between 1 and 10. The client sends a guess and the server replies correct or try again. Be aware that unlike TCP, no connection is established. Each message is independent. We need to initialize datagram socket for UDP protocol. Initialize a random integer value for secret. Again, in an infinite while loop, listen clients using datagram package. parse received data into string and check if that is the correct guess or not. First check if client sends exit. If guess is correct, return correct message. Again, we need to send response as datagram packages. At the end, close the sockets. Now implement client side. Get the number guesses from user from command line using system in. Again, implement an infinite while loop and ask user to enter his or her guesses. Convert that guesses into datagram packages and send using socket. Read response from server using datagram packages again. Convert that response into string. And print out the result. Let's run and test it. Let's see on which trial I will find the correct value. Yes, I found it. Next exercise is about synchronous versus asynchronous file downloads with native HTTP client in Java. In this exercise, we will download 3 audio files from archive.org using HttpClient with both sync and async methods. We will compare time elapses in sync versus async and save the audio files into sync downloads and async downloads directories. First, let's find some sample audio files. Let's use these, The Adventures of Sherlock Holmes ebook. Pick 3 of the file downloads and copy the URLs in the exercise code. Build URLs list. Of course, you can add more URLs to see more benefits of parallel execution. Let's prepare download directories. Use files.create directories. Build HTTP client. Now it is time to download the files. First with the sync method. Calculate time elapses using duration between method. Decode file name to avoid some weird characters in the URLs. To make it more safe, replace weird characters as well. Use resolve method to get the output path. Build the HTTP request. And send it using the client. Check status in response to see if any error occurred or not. On success case, print the URL. Now let's implement the async part. Lots of things will be same, but only the client side will be different. We can use the same HTTP request build block. Client.async is returning completable feature. So we can pass some async method to execute on complete. Again, on successful completion, print out the URL. After getting all completable features, let's wait for all of them to finish. And using duration, calculate time elapsed. Okay, I think everything looks fine. Let's run them and observe what will happen. Sync downloads have started. Let's refresh project and see the directories. Yes, first one is done. Second one is done. Yeah, third one is done as well. It took 4 seconds. Async downloads have started. First one is done. Second one is done. Yeah, you see, async downloads only took 2.4 seconds. Sync downloads took 4 seconds. Next exercise is about memory leak with the ever-growing cache example. Build a website simulation that stores user sessions in a cache. Start application with not enough memory, let's say 64 MB of heap space. Every time a user logs in, a new session with 1 MB per session data is added. But you forgot to remove old sessions. Over time, memory usage grows without band, and finally you will have a memory leak. Let's define session structure that holds 1 MB of data. Let's initialize map that will represent our cache. I will use simple hash map. In the main method, I will iterate 1000 times and create session data for each iteration. On every 100 step, print the cache size. Let's run the application. There is no error because we didn't decrease the available heap space. Let's give only 64 MB of heap space in VM options. Yes, after running with only 64 MB of heap space, we got this out of memory exception. We will use linked hashmap instead of ordinary hashmap in order to resolve this problem. Because when we override the remove eldest entry method, we can use linked hashmap as a LRU cache. It will remove the eldest one when the capacity is full. Okay, there is no error when we run this again because cache size is not increasing more than 10. You can deep dive to memory leak troubleshooting in Java in one of my previous videos. I will leave the link in the description. Let's move to Reflections API exercises. Inspect a class, create a simple class and print name, fields, methods, annotations and constructors. First, let's create an annotation. We need to give retention policy as runtime because we want to read annotation info when application is running. When you use retention policy class, it is compiled but it is not retained in runtime. Let's define person class and use our info annotation. Define some fields, constructors, and methods. This is a public say hello method. And this is a private secret method. Now let's get class instance of person class and let's inspect what is in it. Here is how we can get the fields. Similarly, we can get the methods defined in class like this. And that is how we can get the constructors. And finally, we can reach annotations like this. Okay, let's run and see the output. Yes, we can see the methods, constructors, annotations, fields. Next exercise is about invoking methods and constructors using Reflections API. Invoke a public method of that class, get and set a private field with set accessible true. Create instances by invoking public and private constructors. First, define a sample class. Let's name it SecretBox. Define a public constructor. Another private constructor. A public method. A private one. Get the class instance. Create an object instance using public constructor using Reflections API. Yes, we got the box one with new instance method. Now let's invoke the public method of that box one instance. Now we will get and set a private field with using setAccessibleTrue. Normally it will not allow, but when we use setAccessibleTrue, we can set values to private fields. Let's print the value before and after. And now let's create an instance using private constructor. We will use similar approach. We will use setAccessibleTrue and setAccessibleFalse. Okay, let's run and observe the output. Yes, we can see instance created with public constructor. Real, we can see the output, get and set. Yes, we can see value is modified. And finally, yes, an instance is created using private constructor. Let's move on to generic exercises. This is loot crate exercise. Chests can contain any type of loot, gold, potion, weapon. Implement a generic box class and open different crates safely. Implement open method that returns loot item. First, implement a box class with generic T type. With this put and open methods, we can define any type of box and we can put items. Now here is the gold class that holds amount data. This is potion class that holds type data. And finally, weapon class that holds name data. Now in main method, let's create boxes for gold, potion and weapon. And then let's put items into boxes. And finally, open the boxes and print the items. Yes, looks fine. Next exercise is about lower bounded wildcards, question mark super notation. In this monster cage exercise, a cage can accept monsters of their super types. Implement addDefaults to add orc and elite orc. First define base monster class and then orc class that extends monster class. And finally elite orc that extends orc class. Now let's implement addDefaults method here using super notation. Because of this question mark super notation, we can add orc and elite orc because orc and elite orc are extends from orc class. And in the main method, we define array list using only monster type. We can call addDefaults without any error. Yes, that looks fine. Next exercise is about generics with multiple types. In this quest rewards exercise, each quest yields implement a pair with two generic types and a generic method print pair. Let's start with implementing pair class with two generic types. Here is how we implement print pair method with two generic types. In first example, reward is a game, value is XP. In second example, reward is a potion, value is its rarity text. In final example, k is an integer ID, value is a description. Okay, let's run and observe the outputs. Yes, they look fine. Now it is time to apply all your learnings in this final mini job server project. I want you to note requirements and try to implement it by yourself. Then you can come to this video again and check my implementation. Here are the requirements. Build a TCP server that accepts jobs from clients, runs them on a worker pool, stores the result in a DB, caches recent results, and loads job implementations dynamically via reflection. Use generics for typeset results. Here are the DB tables to create. Job table and job results table. Job table should have ID, job type, payload, status, and created at columns. Job results table should have job ID, result text columns. Protocol should be based on TCP connection and server should expect and return simple single-line strings. Server should support these four types of messages: submit to submit jobs, status to query status of job, result to retrieve result of the job, and a help message to return possible command details. Result model should be generic and should be able to hold any type of result, string, integer, etc. Here are the example jobs to create. First, echo job, that echoes whatever payload is sent as back. Second, hash job, that returns SHA hash of payload. And finally, long running job, that simulates the long running job with thread sleep method. Once a job is submitted, save to DB and submit to executor queue. Implement JobRunner using fixed thread pool executor service. Thread pool size may be number of CPU cores in your machine. Make executor service run jobs based on their job type name. Observe results and update job statuses in DB. Implement server logic with ServerSocket and a cached thread pool such that server can respond multiple client requests. Dispatch client request based on protocol. For example, if submit message is arrived, submit the job to JobRunner. If result message is arrived, return job result to client back, etc. And finally, in order to test the server side, implement a simple client example that sends some submit and result messages. Alright, specs are done. Let's move to my implementation. First, let's prepare DB side. Here are create table queries for job and job results tables. ID, class name, payload, status, and created at columns in job table. Job ID and result text columns in job results table. Here we can see the created table details, columns, etc. Let's run a simple select query against jobs table. Try to insert one item and then select again. Insert into query with specified column and values. Okay, it looks like we need to use single quotation marks instead of double ones. Okay, it worked now. Let's select the item. Yes, here is the item we edit now. Next, let's define the result class and define the example job classes. Define result class with a generic type. Define the constructor. Define public static builder methods. Add getter methods. For jobs, start with an job interface. This run method should accept a string payload that will come from the client and return a result t value. In EchoJob, our work is simple. We will just return the payload coming from client page. In the hash job, we will return message digest of the payload. In the long-running job, we will accept time amount of wait from client and execute thread sleep method to simulate the long-running job. Next, let's prepare DB utilities to save jobs results, and update the job statuses. First, let's define a job class type enum to differentiate job types. Each job type enum value will hold its actual job class instance. Normally, best practice is to get the credentials from environment variables, but we will keep it simple for this demo and we will just put DB credentials like this. I'm getting DB credentials details from our Docker Compose YAML file. Let's copy connection codes from our initial JDBC exercises. Let's check if DB connection is working or not. Okay, there is no error. Connection is working. Now let's prepare basic DB operations helper methods. insertion, update, delete, etc. We will use prepared statements. Set parameters in prepared statement query with the values passed into insert job method. And let's make this query return the ID generated. Now let's implement update status method. ID and status values are passed in this update status method. Now let's implement absurd result method that inserts or updates job result item. Check the SQL query. It first tries to insert item, but if there is any conflict, it updates the existing item. Now helper method to get the status of job. If no job is found, let's return not found message. Similarly, let's implement the result method that returns job results. This method should query job results table. Before moving forward, let's make sure our JobDao utilities are working fine by executing some simple tests. First, let's clean the table. Now let's try to insert a job, but we got an error. No results were returned by the query. We need to append this returning ID statement in our SQL query. Now it is working fine. Let's print the job ID returned from DB. Next, let's execute some other tests for our other utility methods. Update status, absurd results, status, result, etc. Now we catch another problem in our utilities. Okay, we have a copy paste error. We need to use execute update method instead of execute query here. Okay, now everything looks working fine. Okay, let's clean the DB by deleting all items from jobs and job results tables. Now let's implement repository class that will use JobDao utilities. We will implement user-friendly methods in repository and will just delegate the job to JobDao utility. This is just for putting one more layer between business logic and data access. For example, we can change JobDao later without changing anything in our business logic tomorrow. This is how multi-layer application development is done in enterprise world. Move on to JobRunner implementation. We will use ExecutorService to run jobs. Initialize workers ExecutorService with new fixed thread pool static utility method. Here is the submit method. Once a job is submitted, first persist it in DB and give it to executors to run the job. And what actually running the job means. We need to first determine the job type from the past class name value. And update the status to running. We will use reflection to initialize job instance. And execute the run method passing the payload coming from client. Build a result instance. Persist the result in the DB. Update the job status as done. In the error case, save the error message as result and update the job status as error. Put the get status and get results helper methods in JobRunner as well. That delegates to repository. Put a shutdown method to properly close the workers. Now let's implement result cache. As we have seen in the previous memory leak exercises, that hash map is prone to memory leak, so we will use another LRU cache. This LRU cache will hold only maximum 100 results. Now let's use this result cache in JobRunner. Put the calculated result instance in cache. And in the getResult method, first check in cache. If it is in cache, return from cache, but if it is not in the cache, return it from DB. Okay, I think we have a type error here. For simplicity, let's just cast this to string and continue. Now let's implement server logic with ServerSocket and dispatch client requests based on protocol. Let's make this mini job server class autoclosable to use it in try with resources structure. Define new cache thread pool for clients. Initialize a JobRunner. And let's define a running flag with volatile keyword to use it in multiple threads. In start method, let's initialize ServerSocket. When a client request arrives, submit the handle method to client's executors. In the handle method, we will read payload from the client and dispatch operations accordingly. Once client first connected, we will return this OK mini job server try help message to make client aware of possible operations. Reply value will be processing result of client request, or if any error occurs, we will return an error message. In the close method, let's shut down all executors. And here is the dispatch method implementation. We will read client request and process it accordingly. If line starts with submit, we will expect a job type class name and a payload. And in that case, we need to parse job type name and payload from the line. And then submit to the runner. Return the job ID to the client. If client requested the status operation, parse the job ID from the line and query the status of job and return to the client. A similar processing is needed for the result operation. If operation is not recognized, return the error message. Now let's implement main application. Initialize the mini job server and start it. Let's try to run it. Yes, it is working. Now we need to implement a simple client example that sends some submit and result messages. Initialize simple socket to connect to localhost and minijob server port. Print the first message coming from the server, that is a help message. Now let's submit a simple echo job message. And print the job ID. And then let's query the status of the job. And finally, let's query the result of the job. Let's first start the server side and run the client. Okay, we can see the help message coming from server, job ID, and status, and finally we can see the result. It looks like our echo job is executed successfully on server. Now I want to test the mini job server interactively by getting inputs from user from command line. I will get any operation request from user and submit it to server and print out the result. Scanner to get inputs from the user. If user enters exit, just finish the application. Otherwise, just submit the all input to the server. Read the reply from the server and print it to console. Okay, everything looks fine. Let's play with our mini job server. First, start the server side and run the client side. Let's try to submit help and get the help details. Now I am submitting an echo job. We got the job ID as 40. Let's query the status of 40 job. Yes, it is done. And let's get the result of the job 40. Yes, it is simple. It is echo of our message. Now let's submit a hash job. Job ID 41 is created. Let's get the result of the job. Yes, it looks like hash is generated. Now let's try long running job. I want it to take 10 seconds, so I am sending 10,000 as payload. Okay, it's fine. It is still running. Oh, we got an error. Let's check what was the error message. It looks like it is a class cast exception. Let's correct it and retry. Let's return string instead of long in long-running job class. Now we need to stop everything and start again. Okay, I am again submitting a long-running job with 10,000 payload that I want to sleep 10 seconds. Let's check the status. Yes, it looks fine. It is running. Okay, it is done. Let's check the result. Yes, there is no error. It is working fine now. Let's see how DB tables looks like now after creating lots of jobs and job results. Yes, we can see the items generated here. If you find this video helpful, please like it and subscribe to not miss upcoming next videos. Thank you for watching.